All right, it's your friendly neighborhood surveyor. I got today off. It's August. I think it's August 2nd. I waited a while. Been busy, but somebody asked me a question about. I've had a few questions about joining the union and what are the best companies to work for, and kind of what to expect. So I started off in the union, and I did not get vested. I think it takes about 10 years to get vested. And I'm anyhow. Um, but I do see a difference between a person who starts in the union and a person that just starts at a non-union company without knowing anything about surveying. So the person that I'm talking about, he had gotten a copy of the study guide for the exam, and I haven't taken that thing since the late '80s. So I asked him for a copy of it, and I got a copy of it. So I'm going to show it to you later on this video. And what? So what I did is I gave both of the guys that we have working with us as chairman a copy of it. Now, what they do with it is their prerogative, but I'm hoping people look at it. And it's because if you're going through the hassle of getting into the union and actually studying for an entrance exam, it shows everyone that you're interested in that profession, and that you're willing to learn the math that is behind it. So the exam itself, it's not difficult. It's basically just showing that how many degrees are in a circle, like parallel lines, and solving for triangles, and the differences of triangles, and different ways to calculate formulas. Because when you go through the apprenticeship program, a lot of things are formula based. Now, I haven't used a formula in a long time, other than just like right triangle stuff, just because all that stuff's in the data collector. But it is very important to understand the function, because it helps you realize if you're doing the math correctly or not. And when it comes to bearings, which direction you're going. So the other question from the guy was what companies would you suggest, or would I suggest to talk with? And so in Southern California, we are local 12 for operating engineers, and the big companies that are union that I still remember out here are places like Somas. So you're going to do a lot of, or I believe they got the contract with Caltrans, so a lot of highway work. I don't know if this company still exists, but in downtown LA, there was a company I worked for called Mullenhauer Group, and they primarily did high rises. So when I was there, we were working on the Disney Concert Hall and the Academy Awards building. And then most of the companies I worked for while union, we did a variety of work, primarily residential construction, staking, but boundaries, topo, stuff like that. And those are companies like Adcan and Hunsaker and Associates. And there's, believe me, there's plenty more, but those are just some names. So once you pass the exam and you can put your name on the out of work list, then I would contact some of those companies, and see if they're hiring. Let them know that you're interested in getting into the field, and let them know that you're on the out of work list, and that should help. And then the only thing I would do is, we don't really do chaining nails anymore, but I would say watch as many videos as you can about like how to read survey stakes and like stationing and stuff. And if you want me to make some other videos on that stuff, I surely will. But to be able to tell them that you've gotten kind of like a head start on the survey field, because if you're going in the union, you're gonna be working out in the field. So now let's look at that practice exam. Okay, you're gonna have a bunch of chicken scratch on here because I was recording and forgot, or I thought I was recording. Okay, so this is the study guide, and all this is doing is qualifying you to get into the apprenticeship for the surveying. And this is one, I believe, from Local 12 here in Southern California. And they cover geometry, things on triangles, and a little bit of algebra. But it's just learning the fundamentals, because each question we do have to approach in the field, and I'll try to give an example with each thing here. Okay, so like this one here, this is what's important. You have two parallel lines, and let's just pretend like this line doesn't exist. So we have a line going across, but as long as these lines are parallel, so they're giving you the answer right here. You got 35 degrees right there. And I hope you know that there are 360 degrees in a circle around. And so half of that would be 180. So half of this, 180. So you go 180 minus 35 would give you that answer. And then this would be the same as that. This would be the same as that. And you come across this side, your smaller angle is here and here, larger angle is here and here, because these are parallel lines, and this line doesn't change direction. Then you throw another line in here. It looks, just the opposite direction, but it's not, because it's just not on this example. So the same thing. They're giving you one of the angles which solves everything else on this line. So 130 from 180, was at 50. So 50 degrees, come down here, 50 degrees, 130, 130, 130. Then now you're able to solve like these other angles in here, because you got 35, you got 50, and then figuring out what you need here is, there's a formula, it's on the next page, but it's a number of, hang on, let's see. There we go. Number of sides minus 2 times 180. So number of sides, 1, 2, 3, minus 2 is 1, times 180 is 180. So we got 180 degrees inside here, minus the 35, minus the 50, would give you that answer, which again would give you that answer. You subtract this from 180, it'll give you that, which will give you the same as that, and now you're solving all these triangles. And it's just to prove that you know how angles work on lines. And where this would come, where this would come in play on a job is if you're using bearings or azimuths. So if you're starting here, and let's say you're going along this line, then this direction on a bearing would be something, well, let's say this is the center here, north, south, east, and west. So you would know what this angle was, and let's say that was in the middle, so you have this angle, divide by 2. So this angle right here would be this bearing, northeast bearing, and then in this direction, but if you're coming this direction, it'd be a southwest bearing. So as you're going through the apprenticeship program, they're teaching you all that stuff, but you got to have just a fundamental understanding on angles. Circles. I can't say that we use these formulas all the time in the field, because everything is just on the data collector now, but you have to know these formulas to take a test, and that just proves that you know how to push the buttons, and you know how to read formulas. So pi times r square, 2 times pi times r. And what I try to do is, I'm not going to do the math for you here, but let's say I have a 50-foot radius. And now I can solve the circumference. So it'd be 2 times pi, which is 3.14, times 50. Okay, so I got my circumference. I would take my circumference and divide it into quarters, only because on this next one, just to make sure that I'm putting in the numbers right. Okay, so let me go back. So I would figure out the circumference divided by 4, and then give me this this length of arc, or arc length, right here. Then I can prove my math here, so I can give it the same radius. This n with the degrees in the field, we call that delta. So it'd be the degrees. If it's in quarters, you should know it's 45 degrees, because 180, 90 degrees. Okay, got myself there. Told you we don't use it out in the field. So you would know it's 90 degrees, because if you're dividing it in quarters, you have 360, and then half is 180, and half of that is 90. So you would have your 90 divided into 360 times 2 times pi times r, and this length should match what you had over here, just as a check. And I'll show you the same thing like with the right triangle. So know these formulas, because they're not going to give you the formula. At least they didn't do that for us on the entrance exam. What I remember on the triangles, if I had to take this test over again, I don't remember any of these shapes other than a right triangle. But I do remember they either gave it to you in a word question or just shapes. They'd give you this and then A, B, C, D, whatever. And they may even have you solve like the area of one, and it'd be like one like this, where you can make it into 2 right triangles or something. But just know your different triangles, and know how to solve the area, especially on the ones with like either 2 equal sides, because like this one right here, you turn that one into a right triangle as well, and that's a right triangle. But yeah, you can't turn any of these other ones into right triangles to get like area. Yeah, so that's what they just want you to know, different triangles. Out in the field, we deal with a lot of the problems we solve are right triangles. So when you're staking, you're doing like 5x5s or 10x10s and stuff like that, or just to pull off something and to make it square. So know your formula here for the Pythagorean theorem, and I remembered it as like a squared plus b squared. I know people are mad because I'm capitalizing these, but we're surveyors. We capitalize everything. Equals pencils running out of lead. Square root of c. So that's the same thing. And let me see. Let me grab a pen. So a right triangle, to make sure you're doing your math right, we can call this, let's say we call that 4, we call that 3, call that 5. So you'll hear a lot of times, you may be taught this, a 3, 4, 5 triangle. So by using this, if this is A, so 4 square, 16, plus B square is 9, that equals 25, and then the square root of 25 is 5. And now if this was 5 and 5, this would be 707. It's just because we do the math all the time on that. But just to check your math, to make sure you're putting in the numbers correctly, do it through a 3, 4, 5, and that'll prove your math. Stuff like this, they want you to learn how to solve different sides using like limited information. And when I was looking at this today, I don't know if you drove this straight down, so we know that's 3. This is 6. I'm assuming this is 3 and 3. These are right triangles. Now you have 3 here, you have 4 here, so there's your 3, 4, 5, 3, 4, 5. Otherwise, you'd have to do the math, and so on and so forth. So just review, and believe me, there's a bunch of stuff online, YouTube, how to solve triangles and stuff like that, and I would just type in any of this stuff. Right triangles, I use this stuff a lot, and I make the guys who work with me understand it, and they do it kicking and screaming, but we got to make sure things are square, so like if we stake a building, we do building corners, you got to be able to figure out what the diagonal is and to pull a chain across the diagonal. Or if you store the points on your data collector, inverse between them. Whoops, there we go. Hang on. There we go. And you can inverse between the 2 points and figure out what the diagonal is to make sure things are square. So this stuff does come into play every day on the job. At least it does for me and on my crew. This stuff right here, elements of a regular polygon and sum of interior angles. This pretty much covers like a boundary. So just pretend like these are all intersections points, and you're setting up your backsiding. Let's say you're backsiding here, and you're turning an angle right to here, and you're doing that all the way around. Remember that one formula? It's right there. So they have it written a little different, but it's the same thing. Number of sides minus 2 times 180 equals, so we have 1, 2, 3, 4, 5, 6. 6 minus 2 is 4 times 180. What's that, 720? Shit, I think that's right. We have 4, 2, 4, 720. So now we use GPS, so we're not closing traverses anymore. The only time I ever close a traverse now is like setting control and going around the job, setting control, and then checking back in. But you have to know what you're doing and why you're doing it. So this is the check. So if this was a boundary, it'd be angles and distances, and then you would traverse. You'd have a hold, like a bearing, and then you would traverse around and then check back in. So that's what you're learning to do. But at this point here, you're just making sure you know how to read this formula and know what the interior angles are supposed to be. So the answer would be 720. So all these angles would equal 720 added together. And they're just having you add angles. They're not going to do hours, minutes, and seconds. So that'd be your hours, minutes, seconds. So let's say like 59, 24, 36. Hours, minutes, seconds. They're just angles. And here we go again. So remember I told you they're going to have you figure out like an area of a shape. So this is where you start like turning things into right triangles. And so knowing how to do this, there we go, come on. There we go. Knowing how to do that formula there, they should give you numbers. I remember that they gave me numbers, but knowing that formula, you should be able to figure all that out. Otherwise, you multiply this length, and that length will give you the area that's square. Now you got a right triangle, so basically that's half a rectangle right there. So if you had this distance and this distance, you'd multiply those two together, divide by 2, gives you that. Same thing, times, divide by 2 gives you this, because you're eliminating that one right there. And I don't know when I've ever used that, but I mean, not to solve for area, but to maybe calc something out. In fact, I worked with a guy when I was working on the Academy Awards building. The guy was an LS, fucking grumpy guy. We had to work 12 to 16 hours a day, 6 days a week, and it paid great. Got some hazardous pay, union wages, everything was good there. But when he had to do as-built, he made everything into a right triangle. He simplified everything down to a right triangle, and it was freaking amazing. The guy was funny, but just grumpy all the day. And yeah, but everything he turned it into a right triangle, and you can too. And this is, I think, the last part here, which is algebra. Now, you're going to have to look up for these answers because, to tell you the truth, I don't remember how to do these. I remember my examples were something like a times a equals, and then a plus a would equal. So it's having you like figure out how the functions work. So like a plus a would equal 2a, whereas a times a would be a square. So I don't know if this is if this would be a 35. To tell you the truth, I forget. And the only reason why they want you to learn this is because you're going to be learning formulas in the apprenticeship program. So they want you to know kind of like how to use the exponents, how to reduce and all that stuff. Decimals, I mean, come on. If you know this other crap, you should know how to do decimals. So converting inches into hundredths, you just divide the inches by 12. That's what they show you right here, and it'll give you hundredths. If you go the other way, you can do it the other way as well. And but I have just memorized that a foot is a foot, no matter if it's in inches or tenths, and you have absolutes. And it goes something like this. Okay, then 1.0. 3 inches, 6 inches, 9 inches. Okay, so 25 hundredths is exactly 3 inches. And it makes sense. A quarter of a foot is 3 inches. Quarter of a foot is 25 hundredths. Think of it as dollars and cents. And then define the inches, or if you're converting one way to the other, is you going from the absolute, you either minus 8 hundredths or add 8 hundredths to get the hundredths. You can do the same thing. So let's say whatever it was, 2.56. So it'd be 2 feet. We know 5 tenths is the same as 6 inches, and that would give us 6 hundredths left. So it's less than 8 hundredths. So it's not going to be 7 inches. And about every hundredth is a eighth. So we have, what's that? 6 eighths and 3 quarters. Shit, sorry about that. So yeah, when I'm out in the field, I can do this faster, but have a hard time here. So that's it. It'll just be in your head. I try not to give anyone inches, but architect plans are in inches, and you need to be able to convert them into hundredths of feet. So that's where we use that stuff in the field. And that's the only time I really ever see inches in the architect plans, or maybe if stuff with like grid lines, buildings and stuff, commercial buildings. So subtracting negative numbers, again, this is all elementary stuff. You should know how to do this stuff, and if you don't, go online, figure it out. This is not a math class. And again, these are just preparing you, or it's showing the union that you know the fundamentals and how to read formulas, simple formulas. This is not, we're not going into space here. We're geometrical shapes is what we're doing. And that's it. Yeah, that's just my other notes. So I hope that helps, but again, if you learn this stuff, you're way ahead of somebody who knows nothing at all, in my opinion, because at least you're learning. Because if you don't like this stuff, then you have no business being in the field. And if you don't know this stuff, the only thing you're going to be doing in the field is hammering nails and carrying a rod. So knowing this stuff is what advances you to the next step, and that's what the union does well. Is it does train you. It'll and I believe starting wage, at least in California, I have old numbers, but I think apprentice A is somewhere around $26 to $28 an hour, and then certified chainman, which is like 5 years of work, is in the 40s, I believe, right now, and it's the high 40s. Now California's expensive, but it's well worth starting the union. That's the one good thing, or a couple good things I can say about the union. I don't like the way they tell me how to vote, but teaching you the job is fantastic. So that's it. Hope all that helps. Survey out.